hard to pronounce for me in the outside, so they call me HS or just H and Mr. Lee. Yeah, that's fine. The seminar will start with the presentation from Enlight. Enlight is a very close partner of HK for many years, very strong relationship. And this seminar is about the advanced vibration technology. And then our HK production on the show will follow. And after the open presentation, there will be a small customer ceremony. And yeah, please welcome Mr. O.D. from Enlight.
Thank you for the introductions. Everybody hear me okay? So for my talk today, I'm going to be discussing Enlight fiber lasers, including some of the advanced technology we have to optimize beam shapes, and some of the new lasers that we're releasing with HK tools actually here for the first time at SIMTOS. So the agenda for my talk is going to be introduction to Enlight. Who is Enlight? What kind of lasers do we make? And I'll be following that up with Enlight fiber lasers and the motivation for tunable beam quality. And what are the metal cutting advantages that you get with a tunable beam laser? And the more recent advancements in Enlight lasers and cutting, specifically for cutting tools, the Lock Ultra fiber laser, which is in a tool for the first time here at SIMTOS, and some advancements in ultra high power cutting, thick metal, and the brand new 20 kilowatt infinity fiber laser from Enlight, and then have time for questions at the end. So Enlight is a high power semiconductor laser company. We've been around since the year 2000. We're headquartered in Camas, Washington, in the United States. Have a global footprint, over $200 million in sales, greater than 1,000 employees. And we make lasers. That's our whole company. For markets in industrial, microfabrication, aerospace, and defense. We're on the New York Stock Exchange under LASR. So our global footprint, we have applications and technical support, sales here in Seoul, and manufacturing around the world. So Enlight makes high performance and high reliability fiber lasers that have been qualified for standards for use in space applications. We have lasers on ICESat-2, which is a satellite that's used to measure global warming by measuring the height of ice and how much ice is melting. We also have lasers on the Mars Perseverance rover. Both of these missions have exceeded their lifetimes, and the lasers have remained operational, and they're still being used today. In aerospace and defense, we offer applications for countermeasures, guidance systems, and we have a long history of supplying mission-critical lasers into these long-running programs. Enlight's vertically integrated. We have a semiconductor fab. We make our own diode chips, combine those into high-performance, high-reliability fiber-coupled diodes. We draw our own fiber, and we use all three of those components to make fiber lasers with integrated beam control. That's going to be the focus of the talk today. We also make delivery optics as well for some applications. For the industrial fiber lasers, we make lasers from 500 watts up to 20 kilowatts for additive manufacturing, for cutting, and for welding. So this is a lineup of some of the different series of fiber lasers we make. We're going to be focusing today on the Corona CFX series and CFL series, which are lasers for metal cutting. So I want to start by kind of trying to build an understanding of what is the motivation for a tunable beam quality laser. Why would you want the laser beam to change size and shape? Well, it's because metal processing depends on properties of the beam, such as the size, the shape, and the divergence or the angle of the beam. So this plot here is showing representative cutting speed versus metal thickness for a small beam and for a large beam. So a small beam is preferred for thin metal, like 6 millimeters or less, because you can get much higher cutting speeds. But there's a trail-off, and you can't cut very large, thick plate with a small beam anymore. So most people compromise, and they pick some beam in the middle, typical of like 100 microns. But ideally, you'd have a laser beam that could switch between a small beam and cover that whole process window with a single laser. In the applications for welding and additive manufacturing, you kind of get similar benefits by adding beam shaping to the laser, by being able to control the type of welds or the size and productivity of additive manufacturing by switching to the laser beam. For metal cutting, there's a fundamental trade-off. It's a small spot is needed for fast cutting, typically cut with nitrogen, and that a wider kerf and optimized energy distribution is needed, which requires a larger beam. So different thicknesses require different laser beam sizes and shapes. So for a tunable laser beam, what kind of properties would we want out of that laser? We want it to be all fiber, so we're not doing beam shaping in free space, which would degrade the reliability. We want it compatible with fixed and zoom process heads. We want the beam shaping to happen in the laser. Full power available in all different beam shapes, and we want those power distributions to be optimized and be able to also switch beam shapes on the fly. And so Enlight's solution called Corona, the CFX series of lasers, is an all-fiber technology that enables rapid tuning of the beam characteristics. And that's directly inside the fiber laser. This animation here shows the output of the fiber. These are actually measured beam profiles at 5 kilowatts, showing different intensity distributions from a 100 micron flat top to a 200 micron flat top to a 200 micron ring to a 300 micron flat top to a 300 micron ring. So all those different settings are available and programmable into the laser. 5 kilowatts is available in all those settings. There's no free space optics, it's all in the fiber, fast switching, less than 30 milliseconds. And this system's highly reliable. We've tested greater than 20 million beam changes with no change in optical performance. It's a versatile platform, so we have different fiber designs for different specific cutting applications, beam shapes from Gaussian to flat tops to ring beams. And the power scaling is only limited by the silica fiber, so it's currently available all the way up to 20 kilowatts and compatible with both fixed and zoom heads. So we first introduced this product in 2018 and have developed different fibers for this. This is a plot showing the 100 micron core to a 300 micron ring with 3 different guiding regions. So there's a center ring and an outer ring. And so you can control we can control the power distribution between any of those 3 zones. So these are incorporated in high performance cutting tools, HK for example, also employed in some welding tools. So what is the optimal beam shape for metal cutting? Well, it depends on a number of things. It depends on what type of cutting. Are you doing inert cutting with nitrogen or fusion cutting with oxygen? Depends on the thickness of the metal. It depends on the metal type. So this is a little kind of breakdown of most common cutting methods. Nitrogen cutting thin and thick, and then oxygen cutting thin and thick, and what is the optimal beam shape. So for thin sheet, we want a small high intensity beam. So 100 micron is, in this fiber designed the highest power, and that's going to provide the best cutting speed for thin sheet. For thick plate, we can get improved edge quality by using these intermediate settings going up to 250 microns. For oxygen cutting, particularly for thick plate, a much larger beam is needed, which I mentioned earlier, to get a larger curve. And you also get optimized edge quality by using these ring shapes. So for thick plate, we want a much larger beam. If you're oxygen cutting with thin sheet, you can really use any of these beam settings and you'll get essentially the same result. So we did some tests in nLight's applications lab in Camas, Washington, comparing a standard fiber laser with a 100 micron core. Go back. To a Corona fiber laser using its optimum beam setting. This is oxygen cutting a mild steel. So you can see we're getting the same cutting speed performance all the way up to thick metal, but the surface roughness of the part is reduced by a factor of 3 for these thicker cuts. So this plot here is showing some cut samples. The top row is a standard 100 micron. You can see the part is much rougher compared to the bottom row cut with the optimized beam setting using a Corona laser. So this is a zoomed in view of that 25 millimeter oxygen cut part. You can see a much better edge quality on the part that's cut with the Corona compared to the fiber laser. Or sorry, compared to a standard 100 micron. Cutting speed is similar, slightly faster on Corona, factor of 3 lower on roughness, and probably the most important part here is we get a very nice clean edge with optimized curve, so the part always drops out cleanly, so that you can run Corona lasers like 24/7, kind of lights out operation with high productivity. In addition to all like those other benefits, there's a really large focus window when processing with the Corona ring beam. 4 millimeters is just a huge process window for laser cutting, which just means like you have a very stable process from day to day. So there's really no compromises on you get the thin sheet performance as well as benefits at thick, being able to switch between the beams. So HK did some tests comparing a 4 kilowatt fiber laser compared to a CO2 laser. CO2 lasers historically retain a position for superior edge quality for thick metal. You can see here these two cut samples, 20 millimeter mild steel, both have excellent edge quality. One of these is cut with a CO2 laser, one of them was cut with a Corona. So we get the same cutting speed, same roughness, same perpendicularity with a CO2 laser. So there's really no benefit of using a CO2 laser over a fiber laser with beam shaping technology. I'm going to show a video here of cutting of 25 millimeter mild steel. You can see the part just cleanly drops out. It has a really clean edge, and that's due to the optimized curve and minimal taper of the part. And because we have low taper angles and we're cutting with the ring beam, it's capable of cutting very thin features in thick steel. So here's some cut samples, 19 millimeters and 25 millimeter mild steel. The 25 millimeter sample has a 2.5 millimeter web. And so you have a nice clean cut with no melting in between, so you can cut these like really thin parts. So nLight lasers have a bunch of differentiators. In addition to tunable beam characteristics, we have ultra-fast modulation time up to 100 kilohertz, very high stability, very good reliability and serviceability. I wanted to highlight one other feature. It's the back reflection isolation for reflective materials. So nLight lasers include patented hardware back reflection protection, which allows non-stop processing and cutting of copper and highly reflective metal. So like a lot of lasers will void the warranty by processing highly reflective metals, or they'll shut off from back reflecting sensors. Enlight has no problem continuously processing copper, including you get really high back reflections with piercing operations. So the sample on the right, even though it's thinner, produces very high back reflection because you're just piercing over and over again. So we've done samples with 5,000 continuous pierces, for example. So we've continued to develop and innovate this technology and have optimized a new design of the Corona CFX laser specifically for high-speed, thin-sheet cutting. So this is called the Mach Ultra fiber laser. So that standard fiber laser I was presenting data on earlier, it has that conventional 100 micron core with a 250 micron ring and 330 micron outer ring. This Mach Ultra laser has 50 micron core, that's 4 times the intensity of the beam based on the surface area. And so what are the benefits of reducing that core size? We get the fastest thin sheet cutting speeds, the largest dynamic range, and we retain that thick, mild steel oxygen cutting performance I just showed. So in Enlight's applications lab, we compared a 5 kilowatt system, 100 microns with the 50 micron, comparing the thin metal cutting performance and thick metal cutting performance with a 2-inch fixed optics cutting head. And so these are the beam shapes you get from the 100 micron compared to the new Mach Ultra feeding fiber. And you can see the big difference there is in that much smaller core size, which provides much higher intensity on the workpiece. So here are some results I want to share. So for the 100 micron, you can see this diagram showing power, laser power versus cutting speed for that 100 micron. You get an increasing kind of linear at these lower power levels cutting speed as you increase the power of the beam. That Mach Ultra with 50 microns at 5 kilowatts actually outperforms the 100 micron at 8 kilowatts. So it means you can buy much lower power laser. You need like a smaller chiller, etc. And you can get the same cutting speeds you would with a much higher power laser. And that's all with excellent edge quality over a 1 millimeter process window. Those are cut samples cut all across that 1 millimeter process window. Can't really tell any difference in edge quality. The thick metal cutting performance of the new design, it's the same as the previous design. 1 millimeter per minute cutting 20 millimeter mild steel, and excellent edge quality on those cuts. That's as fast as some 6 to 8 kilowatt 100 micron with 2-inch optics. The last topic I wanted to talk about is ultra high power thick metal cutting advancements. And so Enlight has developed some new laser technology around cutting thick metal fast. And so this laser, also being introduced for the first time here, 20 kilowatt Infinity is the name. So there's a trend in fiber laser cutting for higher cutting speeds and for cutting like very thick metal as a replacement to plasma cutting. For these thick metal cutting applications, there's new recipes and cutting methods that are used, and there's some different challenges that we want to address with power scaling the laser. So first off, we need the laser to be compatible with process optics. So we need to avoid heating of the optics, heating of the aperture in the cutting head, as to not degrade the reliability and overheat the cutting head. As you scale the power and start cutting thicker and thicker metal, nozzle damage becomes a huge problem. Especially these ultra high power cutting applications, they use defocused beams, so the beam is moved up into the nozzle, and And so that creates a risk of the laser beam clipping on the nozzle and heating it, so you get damage from the workpiece coming up and then the laser beam coming down. And in general, the beam shapes of higher ultra-powered lasers are not generally optimized for this higher power. So with the Corona CFX lasers, we try to address some of the deficits of a standard laser. I've shown that you get higher productivity, better part quality, lower cost by using these optimized beam shapes. So for higher power, we're trying to do the same thing with tailored beam laser. So the Infinity laser has beam properties that are specifically optimized for fast, thick metal cutting. So it's a 20 kilowatt low divergence beam, and that gives us improved head compatibility and a larger depth of focus. So that means larger process windows. We also get much higher cutting speeds compared to a standard 20 kilowatt fiber laser with a 100 micron. So we're seeing up to 50% faster speeds cutting thick mild steel, greater than 30 millimeters thick. And that's all with reduced heating of the cutting nozzles over those very large focus ranges that are needed for thick metal cutting. So that means less damage to nozzles over time, lower operating costs, more productivity. This is the same all-fiber design. Excuse me, it keeps jumping ahead. All-fiber design for high reliability, the same as CFX Corona. So I'd like to present some results from HK using a brand new 20 kilowatt Infinity laser. They've been doing tests with stainless steel, mild steel, and aluminum. I'm going to share the results for mild steel oxygen cutting, comparing normal 100 micron core 20 kilowatt laser to the 20 kilowatt Light Infinity laser. You can see the red line and the gray line at these large thicknesses. We're getting much higher speeds with the Light laser. These are some cut samples from 30 to 50 millimeters and the relative cut speed compared to a conventional 100 micron. So 45, 50 millimeter thick, we're seeing 50% greater productivity and cutting speed with acceptable edge quality. And so, yeah, I think this is a big advancement for thick metal cutting and is going to potentially replace some plasma-based tools for thick metal cutting applications. And these cutting speeds are as fast or faster than some 30 kilowatt conventional lasers out there. So to summarize, N-Light fiber lasers increase the cutting performance, improve versatility, faster throughput, better edge quality, especially for thick oxygen cutting of mild steel, very high reliability. You all know HK is here, so they are showing tools at this show and at their open house with N-Light lasers. Thank you very much.
So the question is at the Mach Ultra.
Yeah.
So their laser beam is still like having a Corona feature, like beam shaping.
For the Mach Ultra laser?
Yeah.
Yeah. So question is on the 50 micron Mach Ultra. So it's the same beam shaping technology. So we can get all the power of for this example, 5 kilowatt laser, all in any of these beam shapes. So it's 5 kilowatts in a 50 micron beam, 5 kilowatts into this 175 micron ring, and then 330 micron ring. So it's the same technology, but it's scaled down for much higher brightness for in-sheet cutting. And so it's this setting here that allows you to cut, as fast or faster than an 8 kilowatt with this size beam. But if you are processing thick metal, you kind of get the same cutting speed with oxygen using this ring beam as this ring beam.
With that mount ultra, is that achieved through a different type of fiber, or is that achieved within the resonator itself? How do
Is it just purely the 50 micron feed fiber difference?
So, yeah, so there are differences in the all fiber design of Enlight's beam shaper. I'll say is built into the laser. So it's the feeding fiber design that includes this 50 micron core and ring structure, but there's also subcomponents to the fiber beam shaping technology. But the main resonator is the same between these two systems here. Any other questions? Thanks for your time.
Okay, thank you, Mr. Lia. Nice presentation. Yeah. And I'm Yong Lee, and now I would like to present all the products of HA products on the show. This presentation is like watching a movie trailer if I feel the lobby. So we present 12 items on the show, and you can see and feel all the items in detail at the showroom. And yeah, we're going down to the our showing place after this one. Okay, I want to start with the new RS 315. It has a nickname, Royce. This new version of RS is more compact and accessible and adaptive than the predecessor. As you can see, the comparison between the two pictures, the shorter in length, and the front door is more wide, and side door is kind of automatic. And the RS is one of the fastest machines in the market. We are very proud of this RS series. And the maximum acceleration in X and Y axis, in a single axis with this acceleration can reach 2.5 G. And for the Z axis, the maximum acceleration can reach up to 4 G. So thanks to that, you can see the, this is general, normal frog grip, have motion between the 2 points. But that's to the very high acceleration in the G-axis. We can realize the like this shape, a scale like maybe it's like a UFO motion. Yeah. So this shape of moving guarantees the minimizing the collision to the tilted pieces. And next, in the SIMTOS, the Ultra is introduced by Mr. Odi. And it's in combination with Ultra and Procoder, and it has a voltage changer. The 16 volts can be handled with this device. And beam center and distributor is installed. And this would be the basic device for all the HK machines. I would say this combination is the most efficient solution below 1 inch thickness cutting. The overall performance is quite comparable to 8 kilowatts with the help of Ultra and the high dynamics of RS machine. So this is a real benefit, I think. Low power consumption, it guarantees a high productivity. So we can see the our purpose is can cover result from RS. And yeah. The orange bar is a 6 kilowatt. It's a reference as a 100%, and you can compare the other Mount Ultra and 8 kilowatts in the height. So, in case of aluminum, nitrogen cutting, yeah. In this area, so the cutting speed can be double to the compared to the 6 kilowatts, and yeah, it's really similar performance of 8 kilowatts. In terms of stainless steel, nitrogen cutting, yeah, the tendency is similar. Below the 8 millimeter thickness stainless steel, we can see that also the comparable cutting speed to the 8 kilowatts. But yeah, above the 10 millimeter thickness stainless steel, yeah, in the range, the power matters. So the speed of the Mount Ultra and RS is down to close to the 6 kilowatts. But Mount Ultra is close, same or the better in every aspect than the 6 kilowatts. You can see the milestone result here. And this is a FE series here you can find in our showplace, FE 4050. This is a variation of our standard model of FS. FE uses the same control system of CS. At the show, we prepared 20 kilowatts in combination with the smart cell 4015 also. And you can see the demonstration of mixed gas cutting at the show place. As you know, mixed gas cutting is a nice solution for high power high-speed cutting. And as you know, recently it's getting more and more popular. So we are trying to optimize high speed and the gas mix combination. So you can see soon the more advanced cutting result from HK. And this is HD series, one of the new products of HK. Though its target is the cost reduction. Though it's a project-oriented machine, all the basic features are well included. It has proportional gas control. Some very cheap machines don't have this proportional gas control. It's logically compatible with simple add-ons, so we made no compromise in cutting quality. So the SIMTOS at this show is 6 kilowatts, a 6 kilowatts head and double stage shutter table is included. This new smart cell. It has a variant of 3015, 4015, and 4020 is also available with either single or double deck. The sheet separation functionality is greatly improved. As you can see here, we are using 4 types of sheet separation devices, maximum velocity, and as such an tilting and vibration devices added. It is fully integrated and can operate seamlessly with our cutting machines. So in terms of capacity, 3 tons is available on the loading deck, and lifting capacity is up to 1,000 kilograms, 1 ton, which means you can handle around 20 millimeter thick material. And at the show, you can see this new smart cell. Yeah, as I told you, it will be every 4050. Here is our nozzle changer. It handles 16 nozzles, and all the set up and operation of fully integrated new HMI. This is a beam center monitor. This is really helpful for operator to check the beam alignment as well as the nozzle condition at the same time. Actually, yeah, from my experience, it's a really working procedure to check and adjust the beam center with the traditional tape method because I have a very poor sight. And one thing I have found from with the development of beam center viewer and nozzle viewer, the adjustment of the beam alignment is more sensitive than expected. So if you understand it, this alignment is okay for the tape method, but with the large monitor and camera system, the precise beam centering was not satisfactory, just with tape method. So it's more precise and more instant. It takes just a few seconds. Okay. Yes, sir?
Is this only on the Royce, or will this be offered on the,
For all our standard machines with Siemens. Yeah.
FS,
FS and
Royce?
FL, yeah. This is our prototype, and we are making a production version now. So it will be more smaller. Yeah. And so far, for the FL is a different configuration and different space for this camera. So it will be developed. I think there should be some mirrors and different installation is needed. So we are planning for the FL version. So this is a new HMI. Yeah, I'm happy to introduce our totally new HMI with the developing tool with CC. It has a very intuitive and easy to use. It also provides an online update and it has various features. I cannot explain all the features it has, but you can experience with a simulator down there. Yeah. And we launched HK Insight. This is a monitoring and analysis system with cloud server, and it's a real-time monitoring is also possible. And it uses a standard OPC UA protocol from the machine to the cloud server, which means the OPC UA is a standard protocol for Windows 4.0, so you can understand that we are ready for Windows 4.0 with the help of this OPC UA protocol. And it can monitor up to 500 parameters, and among the 50 parameters can be measured real time. And this is a 5 hours. Yeah. We can tell 5 hours. Yeah, real time. So it will be a great help for monitoring the machines and statistics and working conditions, machine conditions, and so on. You can also see how it works at our show site. We also have, we prepared the PC version of the interface terminal down there, so I hope you look into that deeply. And this is a tube machine, 5270. This was equipped with 6 kilowatts of this power, and this can handle up to 6.5 meter long pipe with automated size detection system. For round-shaped tubes, it can handle up to 275 millimeter, and for the square tube, as you can see in the slide, we can handle the 2 meter square. And I would say this is well balanced. I don't say this is very special or almost a system, but it's very well balanced. Will offer a low price. So its speed is 120 round per minute. The maximum acceleration is 1.2 G. This is press brake. It's a combination with the rubber arm. It provides fully automated bending processes, and PRC 2040 version model uses a motor-driven system, which means it's fast and efficient. The robot arm can handle up to 50 kilograms. This combination has been used for the in-house production of HK for 1.5 years, over 1.5 years, and you can also see the document. This is another press brake model in the PRCV, 3200. This can handle 3 meters. The 30 means 3 meters, and the maximum bending force is up to 2 tons. This is best in class, I can say. Best in class approaching return speed to 100 millimeter per second, thanks to the so-called S-boost system. And it has roll-out types of chronic table, and it can be set up by 2D, very intuitive interface, and we can check out the setup result in 3D visualization. So also robot integration machine. Yeah, number 12, last but not least, this is HK11 1010C deburring machine. And this is a simple machine. It uses a double crossbar system. The key features of this system is it's very easy to set up, and maintenance also very easy. This is a very big advantage of this deburring machine. This is the last part of my presentation, and thank you for your attention. I hope you enjoy this show. Small ceremony of customer appreciation ceremony.
Thank you everybody for joining me today. I'd like to hand out some awards. We have some very special guests from the United States, and we'd like to show our appreciation to them. So, these are some of our key accounts in the United States. We have a lot of customers, but these customers are very special to us. Okay. First, I want to recognize Brown Equipment, Mr. Rusty Caps. He has 3 FS3015 4Ks, and he just got 2 new RS 12Ks. All right. Rusty, if you could please come up here at this time and accept your award.
One second.
That's okay. Thank you, Mr. Chicken. Thank you for that. Next, of course, CMA, Christian Eva. Come on up. Two days, we have one that will be installed very soon, I promise you. Yes. So, congratulations, Chris. Right here, sorry, put right here. You. Oh, and of course, last but definitely not least, Mr. Matt Hoagland. All right, 6 lasers located throughout the United States, and we actually just recently purchased a new one, a FS60 25 with a 10K Corona. Nice. Hold on real quick, Matt. Special appreciation again for your new purchase. So you want to reward you with a certificate of appreciation.
So Matt, how was you? They just placed the order for the big machine, the FS6025 10 kW Corona last week.